Okay, everyone, today we're going to look at Lewis structures. I'm just going to work through a bunch of them for you to show you how these go. So if I look up here at number 1, I've got a carbon with 4 valence electrons, and I've got hydrogens, 4 of them, that each have 1 valence electron. I have a total of 8 valence electrons that I'm going to use to draw this structure. Carbon here has its 4 valence electrons, and each hydrogen has 1 valence electron. And because they're both nonmetals, they will share, and these 2 electrons will occupy orbitals in both the hydrogen and the carbon and make up that structure. And since we have 4 of them, we're going to put them on. These 2 will share and make a bond here. These 2 will share and make a bond. And I've used up 2 electrons here, 2 here, 2 here, and 2 here for a total of 8 valence electrons, which is what I have. So that is my completed structure. I won't have those 2s in there as part of that, but I'll have hydrogen singly bonded to the carbon to make up all 4 of those spots. Okay. I'm going to work over here on H3O plus. This is an ion, so I'm going to have to pay attention to that. Right? I've got 3 hydrogens, each with 1 electron. I have an oxygen with 6 electrons. So 6, 7, 8, 9 looks like I have 9 valence electrons, but this plus 1 here, that tells me that it's missing an electron. So instead of 9 electrons, right, I'm going to be missing an electron, so I have 8 valence electrons total. Okay, so if I look at oxygen and hydrogen, I know hydrogen can never be in the middle, so I've got to look at oxygen. Here is oxygen with its 6 valence electrons. It's easy to bring in a hydrogen here, give oxygen a 7th one and hydrogen its 2nd, and bring in another hydrogen here to give it its oxygen its 8th and hydrogen to get its 2nd there. But then what do? Well, this is where I remember that electron there. That plus charge means I was missing an electron. So I'm going to take out an electron. Okay, and that gives me a place for that other hydrogen here. So if I take that hydrogen and put it in here, right, then I'm going to put these 2 electrons here and make a bond. This hydrogen has its 2, and this oxygen now has its 8. So there's 2 here, 2 here, 2 here, and 2 there. Make 8. So I have 8 valence electrons on there. My structure will look like that. That's a bond there. Now, because it's got a charge, right, once again, it's a charge, so I have to put the whole thing in brackets and put its charge on the outside to finish the Lewis structure for that atom. So let's take a look down here and go to BF3. Boron is an interesting one because it's only got 3 valence electrons. And fluorine has 7. I've got 3 of them. So I've got 21, 22, 23, 24 valence electrons total. Okay, but boron is one of those elements that violates the octet rule, right? It's got 3 electrons, and each fluorine needs just 1 more. So if it shares with each fluorine, we'll get it. And I'll put the remaining ones on here. So we have all 1, 2, 3, 4, 5, 6, 7, 8. Here's one from boron, one from fluorine to make 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And that bond represents 7 and 8. So now I've got 8 over here, and 8 over here, and 8 over here. But we're supposed to have 8 valence electrons for the most part, but boron is one of those that violates the octet rule in having too few. And so this is actually our correct structure for BF3. All right. Over here, I've got an ion now. Again, I have nitrogen with 5 valence electrons. I have a hydrogen with 1, and I have 2 electrons from the charge right there. And so I have a total of 5, 6, 7, 8 valence electrons to use in this structure. So here's nitrogen, and it's got 5 valence electrons. Right? I'm going to bring in a hydrogen and its electron, and those 2 electrons right there will make a bond. So I'm going to change that to a line to represent the bond. And then I'm going to bring in those 2 electrons in there. I've got 2, and I've got room for 1 there and room for 1 there. So now I've got my 1, 2, 3, 4, 5, 6, 7, 8 electrons in there, right? And it's an ion, so I put it in brackets. And put its charge there. All right, let's take a look at HCN. Hydrogen has 1 electron. Carbon has 4 valence electrons. And nitrogen has 5 valence electrons. So that's going to be 5, 6, 7, 8, 9, 10 electrons. 10 valence electrons. So let's see how this works. Here's carbon with its 4 electrons. Nitrogen with its 5 electrons, and hydrogen with its 1 electron. Okay. Well, these 2 can bond right there, and these 2 can bond right there. And I've run out of electrons. I do not have enough now. I have 1, 2 here, 3, 4, 5, 6 from that bond, 7, 8, 9, 10. But my carbon does not have enough electrons, and neither does nitrogen. They both need to have 8. So what happens is that these electrons will come in and form a bond there. They will no longer be out here. Okay? And same with these 2. They will come in here and make a bond right there. So then we'll get rid of them out here. And this will be our structure for HCN. All right, and then this one, NH4, nitrogen has 5 electrons, hydrogen has 1, but I've got 4 of them, and then this +1 charge means -1 electron because I'm missing 1. Okay, and so since I'm missing that, well, let's see, 5 and 4 times 1 is 4, so that's going to be 9 minus 1 is going to be 8 valence electrons. Okay, so let's put this in here. I'm going to put the nitrogen in the middle. It's got 1, 2, 3, 4, 5 valence electrons. Okay, and each hydrogen can come in here and share an electron. Nitrogen make a bond. Hydrogen is going to share an electron with hydrogen and make a bond. Hydrogens come in and share an electron and make a bond. But I've got a 4th hydrogen to go, but I've got this one right here. I have to lose an electron because of that +1 charge. So if I get rid of this electron here, I have a space for my 4th hydrogen to come in and make a bond. So then I have to put this whole ammonium ion in brackets and put its +1 charge out there. And that is how I do Lewis structure drawings for simple ions and simple molecules.